Today we're looking at parallelograms. So we are going to use side angle side to prove parallelograms are congruent. And then we're also going to look at some different properties of parallelograms. So let's just begin with the theorem that says that opposite sides of a parallelogram are congruent. So opposite sides. So remember, opposite means that they don't share a vertex. So this side would be congruent to this side, and this side would be congruent to that side. And if you notice, remember whenever we have a parallelogram, we should be able to make a triangle out of it, right? And so when we do that, we actually get this third side that is congruent to itself, right? And then, of course, if you're drawing a diagonal and you have a parallelogram, that means those are parallel sides, which means you have a transversal. And if you have a transversal, then that means alternate interior angles are congruent. So if alternate interior angles are congruent, then that means you have side, angle, side, right? Side. So side angle side congruence for parallelograms, that proves that parallelograms are congruent if they have a side angle side, right? So you could say that parallelogram DABC is parallel to parallelogram, congruent to parallelogram SPQR, and the reason would be side, angle, side, right? Side, angle, side. So that's how you can prove if two parallelograms are congruent to each other. And the reason why is because they have this identical side there. Okay, so a next theorem is that if you have a quadrilateral, which is just a four-sided polynomial, if you have a four-sided polynomial quadrilateral, you can say that it's a parallelogram if the diagonals bisect each other. And what that means is that, well, here's a diagonal, right? And if I were to draw the other diagonal, then what I'm left with, those are congruent to each other, right? And just like this right here is congruent to this right here, right? So the diagonals bisect or split each other in half. Okay, next theorem is that rectangles also have diagonals that are congruent. So diagonals of a rectangle are congruent to each other. Notice that we didn't say that the diagonals of a parallelogram are congruent to each other. They just bisect each other. They're not necessarily congruent. However, diagonals of a rectangle are congruent. Okay, so the next theorem says that the sum of the measures of the four angles of every convex quadrilateral is 360. So just like a triangle added up to 180, the angles of a quadrilateral will always add up to 360. And the reason why is because a quadrilateral is made up of two triangles, and since a triangle has 180 and 180 is 360. Our next theorem says that opposite angles of a parallelogram are congruent. And then consecutive angles are supplementary. So consecutive means that they share a segment, right? They're with the same segment. And to say that they're supplementary means that they add up to 180 degrees. So angle 1 and angle 2 here would have to add up to 180. That's what supplementary means. Our next theorem says that if the opposite sides of a quadrilateral are congruent, then that quadrilateral is a parallelogram. That's almost the opposite of the first theorem that we talked about. The first theorem says that if we have a parallelogram, then the opposite sides are congruent. And now we're saying if the opposite sides are congruent, then we have a parallelogram. And our next theorem says that if we have a quadrilateral that has one pair, they just have to have one pair of parallel sides, and those sides are congruent, then we have a parallelogram. Okay, so let's do some practice. I want us to determine if this is a parallelogram. And so we have to say yes or no. So for this figure here, this would be a parallelogram, and the reason why is because we have an angle side angle, right? And so for this one, is this a parallelogram? And the answer would be no, it is not a parallelogram. All right, so here we are. We have another parallelogram. The answer to this one is also no, it is not a parallelogram. And then for this one, is this a parallelogram? The answer would be yes, because the diagonals bisect each other. And then we have this one. This one is also yes, because we have opposite angles are congruent, so that would be yes. Last one. So this one would be no. And the reason that it's no is because we have 120 and we have 60, right? But we don't know what the opposite angles are, right? So those opposite angles could be anything. So because of that, this is not a parallelogram. All right, go try some problems.